Hi all, welcome to another session of Boilchem Tutor. In this session, I am discussing about the heterocyclic compounds. In that, I am mainly discussing what is heterocyclic compounds, what are the classification of heterocyclic compounds, and how will you name the heterocyclic compounds in IUPAC way. So let us come to the first topic, that is what is heterocyclic compounds. As the name itself, it is a cyclic compounds. And in that cyclic compound, it should contain at least one heteroatom other than carbon atom in the ring are called as heterocyclic compounds. The heteroatom present in the heterocyclic compounds can be nitrogen, oxygen, sulfur, silicon, phosphorus, boron, and so on. The word heterocyclic is derived from a Greek word in which heteros means different. Consider the compound like cyclic ethers or cyclic esters like lactones or cyclic anhydride. In these compounds, there are a heteroatom in the ring, but they are not generally considered as a heterocyclic. Why? Because they are highly unstable and they have a tendency to convert to open chain compound by hydrolysis. So compounds which are generally regarded as a heterocycle should contain at least 5 or 6 membered ring. Another important condition to be a heterocycle is that it should be highly stable. That means it should not change into an open chain compound by any methods. That means my hydrolysis or my any substitution reaction, it should not change into any open compound. Another important condition is that it should contain a slight degree of aromatic character. So heterocyclic compound can be defined as those compounds which contain 5 or 6 membered ring and should contain at least one heteroatom as the ring member, and they should be highly stable and they should possess a slight degree of aromatic character. So let us move to the next topic, that is classification of heterocyclic compound. In the classification of heterocyclic compound, they are generally categorized into 3. So first category is the 5-membered heterocycle. In the 5-membered heterocycle, they are actually derived from benzene, in which they are obtained by the replacement of one carbon-carbon double bond of the benzene by a heteroatom with an unshared electron pair. So let us move to some examples of 5-membered heterocycle. And in 5-membered heterocycle, first compound we can take is pyrrole. Pyrrole is a 5-membered ring and it contains one heteroatom, that is nitrogen, and it has having a one lone pair of electron on the nitrogen atom. Next compound is a furan. Furan means it is again a 5-membered heterocycle and it contains oxygen as the heteroatom and it contains an unshared pair of electron on the oxygen atom. Next compound is a thiophene. Thiophene means it is also a 5-membered ring containing sulfur as the heteroatom and with unshared pair of an electron. Now let us consider the 5-membered heterocycle containing more than one heteroatom. In that, main example is oxazole. Oxazole, it contains nitrogen and oxygen as the heteroatom. Next is the pyrazole. Pyrazole means it contains 2 nitrogen atoms, and in thiazole, thiazole is another example of 5-membered heterocycle in which it contains nitrogen and sulfur as the heteroatom. Another important example is imidazole. Imidazole also contains 2 nitrogen as the heteroatom. Another example is tetrazole and it contains 4 nitrogen as the heteroatom. Next we can move the second classification of heterocycle, that is 6-membered heterocycles. In 6-membered heterocycle, it is derived from benzene and it is obtained by the replacement of one carbon atom from a benzene ring by a heteroatom. So let us move to one of the important example of a 6-membered heterocycle, that is pyridine. Pyridine is actually a 6-membered heterocycle and it contains nitrogen as the heteroatom and it is obtained by the replacement of a one carbon atom of a benzene ring by a nitrogen atom. Next, we can consider some of the example of 6-membered heterocycle containing more than one heteroatom. In that, mainly it includes pyridazine, pyrazine, and pyrimidine. So in pyridazine, that is 2 carbon atom, that is adjacent carbon atom of the benzene ring are replaced by 2 nitrogen atom is termed as the pyridazine. And pyrimidine means if first carbon atom and third carbon atom are replaced by nitrogen atom are termed as the pyrimidine. And pyrazine means if first and fourth carbon atom of the benzene ring are replaced by nitrogen atom means it is pyrazine. Next important examples of six-membered heterocycle is triazine. Triazine means it is a six-membered ring and it contains three heteroatom, that is three nitrogen as the heteroatom. And this triazine can exist in three isomeric forms, that is 1,2,3 triazine. Then next is 1,2,4 triazine and again one more isomer, that is 1,3,5 triazine. Next we can move to the third classification of heterocycle, that is condensed heterocycle compounds. In that condensed heterocycle compound, it contains two or more fused rings and which may be partly carbocyclic or which may be partly heterocyclic. So one important example of condensed heterocycle is quinoline. In quinoline, it contains a benzene ring which is fused to a pyridine. So one benzene ring which is completely carbocyclic in nature and other part is heterocyclic in nature. And this quinoline can exist in another isomeric form, that is isoquinoline, where the position of nitrogen atom is different. Another important examples of condensed heterocycle is indole. In this indole, it contains a benzene ring and which is fused to a pyrrole. Next important example of condensed heterocycle is the benzene ring which is fused to a 2 nitrogen atom containing 5-membered heterocycle, and in this it is named as benzimidazole. Next we can discuss the occurrence of heterocyclic compound, that is where they are formed. Actually they are widely distributed in nature and they have so many fundamental importance for the life processes. One is nucleic acid. The nucleic acid play an important role in the development and reproductions of all forms of life. That is, they play an important role in the protein synthesis and transfer of genetic information. So these nucleic acids are actually consist of three parts. One is sugar and other is a base and next is a phosphatic group. And this base is actually made up of a nitrogen heterocycle and it belongs to following two classes, that is purine and pyrimidine. Another important occurrence of heterocyclic compound is in hemoglobin, which is a red color pigment present in the blood, as well as in the chlorophyll. It is a green color pigment present in the plant. Both contain a nitrogen heterocycle, that is porphyrin ring. Another important distributions of heterocyclic compound is in certain vitamins like vitamin B1, B3, B6 as well as in vitamin C, that is ascorbic acid, etc. Again, certain amino acid, namely that is an essential amino acid like histidine, proline, tryptophan also contain some heterocyclic rings. So all these compounds are made up of one or more heterocyclic ring. That is why a great deal of research work is concerned with the method of synthesis of heterocyclic rings and studying their properties. Next, we can discuss the naming of heterocyclic compound, that is how they are named by IUPAC way. So first we can discuss the naming of a monoheterocyclic compounds. By naming the monoheterocyclic compound, we have to name the heteroatom as the prefix. That is, we have to first name the heteroatom as the prefix. Then the size of the ring is expressed as the suffix. So if our heteroatom is nitrogen, then it can be named as Asa as the prefix. Again, if the heteroatom is oxygen, it can be prefixed as oxa. Again, if it is sulfur means it can be prefixed as thia. Then if it is phosphorus means it can be prefixed as phosphor. Silicon means it is silla and boron means bora. So let us consider a 3-membered nitrogen containing monoheterocyclic compound. So this nitrogen monoheterocyclic compound, that is 3-membered, can exist in unsaturated, that is it can consist a double bond and it cannot consist a double bond, that is it can be saturated. So if it is unsaturated 3-membered nitrogen monoheterocyclic compound means its suffix used is irene. And if it is saturated 3-membered nitrogen monoheterocyclic compound, the suffix used is iridium. So for a 3-membered unsaturated nitrogen monoheterocyclic compound, the name can be acerine as the IUPAC name, and for a 3-membered saturated nitrogen monoheterocyclic compound, the name can be aziridine, because aza is for the nitrogen atom and iridium represents the suffix, that is the ring size of the heterocyclic compound. Again, for a 3-membered oxygen heterocyclic, the suffix can be different. For a 3-membered, if it is fully unsaturated oxygen monoheterocyclic compound, the suffix used is irene, that is IREN. Then again, for a 3-membered oxygen monoheterocyclic compound that is saturated, if it is fully single bond, and then it can be named as the suffix, that is iran. So for a 3-membered oxygen unsaturated monoheterocyclic compound, it can be named as oxirene, that is oxa for the oxygen atom as the prefix and irene as the suffix, that is oxirene. And if it is oxygen 3-membered unsaturated monoheterocyclic compound, it can be named as oxiran, that is oxi as the prefix, that is ox for the oxygen, and suffix, that is iran for the ring. So coming to the 4-membered ring, and 4-membered nitrogen containing monoheterocyclic compound, and if it is unsaturated, the suffix used is ete. And if it is an 4-membered ring nitrogen saturated monoheterocyclic compound, means it can be named as the suffix etidine. So it can be named as acet for a nitrogen 4-membered unsaturated heterocyclic compound, and acetidine for a 4-membered nitrogen saturated heterocyclic compounds. Again, coming to the 4-membered oxygen heterocyclic compound. In the 4-membered oxygen heterocycle also, it can be unsaturated and saturated. If it is unsaturated oxygen monoheterocyclic compound, the suffix, that is for the ring size, the suffix used is et. And if for the saturated oxygen heterocyclic compound, it can be used as etan. So for 4-membered oxygen unsaturated heterocyclic compound, it can be named as oxet. And for 4-membered oxygen saturated heterocyclic compound, it can be named as oxetan, that is ox for the oxygen and etan as the suffix, that is for the ring size. So coming to the 5-membered nitrogen monoheterocyclic compound, again it can be saturated as well as the unsaturated. So for a 5-membered nitrogen monoheterocyclic unsaturated compound, the suffix should be ol. And for a 5-membered nitrogen saturated monoheterocyclic compound, the suffix should be uldi. So for a 5-membered nitrogen unsaturated monoheterocyclic compound, it can be named as azole, and for a nitrogen saturated monoheterocyclic compound, it can be named as azolidine. Similarly, for a 5-membered oxygen and sulfur containing heterocyclic compound, and it can be saturated as well as the unsaturated. So if oxygen and sulfur containing unsaturated monoheterocyclic compound, the suffix should be ol. And again, for an oxygen and sulfur 5-membered saturated heterocyclic compound, the name should be olan. So for a 5-membered oxygen unsaturated monoheterocyclic compound, it can be named as oxol. And for a 5-membered, if it is saturated, that is oxygen monoheterocyclic compound, the name can be oxalan. And if it is sulfur, means it can be thiol, and other can be thiolan. So coming to the 6-membered nitrogen heterocyclic compound. So in this nitrogen 6-membered heterocyclic compound, it can be again saturated and it can be unsaturated. If it is unsaturated, the suffix used is ine, that is ine, and if it is saturated, means it can be named as the suffix, that is perhydroene. So for a 6-membered nitrogen unsaturated heterocyclic ring, means it is commonly named as pyridine, but IUPAC way it can be named as acene as the name. that is Asa for the nitrogen atom and En for the suffix, that is ring size. And for a 6-membered ring and nitrogen containing saturated monoheterocyclic compound, the name can be, that is IUPAC, it can be named as perhydroazine. Next we can discuss when any substituent are present in a monoheterocyclic compound, how we can name in an IUPAC way. So if substituent is present in a monoheterocyclic compound, numbering should start from the heteroatom. Then it should move in the direction where the substituent gets the lower position. So if two heteroatoms are present in a monocyclic compound, then we have to look for the priority. That means which heteroatom will get more preference. So if there are two heteroatoms, for example, if one is oxygen and other is nitrogen, first we have to consider their group number. So oxygen belongs to the 16th group and nitrogen belongs to the 15th group. So atom having the highest group number is given preference. That is, oxygen will get the lowest number, then followed by the nitrogen. Again, if the group number of the heteroatoms are same, for example, if it is oxygen and sulfur both belong to the 16th group, then the lightest atom will get the higher preference than the other. That is, oxygen will get the higher preference than the sulfur. So look at the first structure, that is, it contains a 6-membered ring and with one nitrogen as the heteroatom, and there is again one substituent, that is a methyl group. Again, if there is a substituent, and the numbering should start from the heteroatom. So first will be the nitrogen atom and then it should move in the direction where the substituent get the least position. So it should move in the anti-clockwise direction and then we can name as 3-methyl-azine, that is Aza for the nitrogen atom and En for the ring size, that is suffix. So look at the next structure. It contains a 5-membered ring and in which oxygen and nitrogen heteroatoms are there. And if there are two heteroatoms, first we have to take the group number. That is, oxygen belongs to the 16th group and nitrogen belongs to the 15th group. And at group having the atom having highest group number will get the preference. So we have to number from oxygen and then to the nitrogen. Again, there is one more methyl group is present and that is at the 5th position, because when we are numbering, oxygen will get the first position and then to the nitrogen means then it should numbering should start from the go through the clockwise direction and then the 5th position only we will get the methyl group. So it can be named as 5-methyl-1,3-oxazole as the IUPAC name. So look at the next structure. It is a 6-membered ring and it contains two heteroatoms. One it is oxygen and other is sulfur. And when we are considering their group number, oxygen and sulfur belong to the group 16th. That means same group. So the lightest element atom will get the higher preference. So we have to number from oxygen. Then to the sulfur. Again, second position there is a methyl group. So it can be named as 2-methyl-1,4-thioxine as the IUPAC name. Again, for naming a fused heterocycle or a condensed heterocycle, we have to follow some instruction. That is, the heterocycle ring having maximum number of a ring with a simple name should be chosen. Again, if more than one hetero rings are present, then nitrogen containing ring, that is nitrogen containing heterocyclic ring should be given preference. That is, it should be considered first, then the next heterocyclic ring. So if the heterocyclic ring does not contain nitrogen means the order of the preference of the fused ring compounds or condensed heterocycle is mentioned from the above rules of monoheterocyclic compounds. So look at the structure for naming the condensed heterocyclic compound. And in this structure, we are having, first we have to choose a maximum number of heterocyclic ring with a simple name should be chosen. And in this compound, it is isoquinoline. Then we have to number the isoquinoline, starting from 1 at the carbon position and then 2 as the nitrogen, like that. And then after numbering, then To distinguish the isomers, the peripheral side of the parent compound should be lettered as A, B, C, like that. That is C1 and nitrogen, that is first and second position, it should be lettered as A, like that it should be followed. So after numbering the isoquinone and after lettering the peripheral sides of each parent compound, then we have to find the fused phase where the naphthalene is attached. And we found that 8, 9 position, that is H phase, a naphthalene group is attached. Then we look the naphthalene numbering way, that is it can be numbered as like this. And when we look the phases, that is H phase and 2 and 3 position of the naphthalene ring is attached to the isoquinone, that is H phase. So it can be named as naphtho group is attached, so naphtho, then 2 and 3 position it is fused to the isoquinone. So it can be named as naphtho 3, 2 and phase. Then phase we have to tell, that is H isoquinone as the IUPAC name. Let us look at another example. In this compound, there are two heteroatoms are present. And again, while naming a fused heterocyclic compound, we have to choose the heterocyclic ring as the parent compound. So in this, the heterocyclic ring, there are two heteroatoms, nitrogen and sulfur, and we have to find the preference, who will get the higher preference. And sulfur belongs to the 16th group and nitrogen belongs to the 15th group, and so 16th group element will get the higher preference. So we have to number from starting from sulfur then to the nitrogen. So it is actually a 1,3-thiazole and it is a parent compound. So after identifying the parent compound, that is 1,3-thiazole, we have to number them, and then after numbering we have to letter them the peripheral side of the parent compound. So after lettering, we found that 4th and 5th position there is a fused ring, that is naphthalene, and 2nd position there is again one substituent, that is an ethanoyl group. Here fused phase is D, that is 4th and 5th position it is D, that is a fused phase, and then consider the fused phase, here there is a naphthalene. And when we are numbering the naphthalene and first second carbon it is fused to this thiazole. So it can be named as naphtho 2, 1, then we have to number the phase, that is D phase, and that is 2, 1, D, then 1, 3 thiazole. Again there is one more substituent, so it is at the second position of the 1, 3 thiazole, so it can be named as 2 ethanoyl naphtho 2, 1, D 1, 3 thiazole as the IUPAC name. So that is all in this session. Hope you understand how to name the heterocyclic compound and what are the classification of heterocyclic compound. Stay tuned for the next session. Till then, bye.